Okay, let's talk about today's question, 282 expression add operators. We have a string containing only digits 0 to 9, and we have our target value. We need to add binary operators, addition, subtraction, and the multiplication between the digits, so they evaluate to the target value. And we have to return all the possibilities, all the possible ways of adding those operators into the string. Let's look at some examples. The first example is 1 to 3, target is 6. We can add 2 addition signs in between, and 1 plus 2 plus 3 is 6. Or we can do multiplication as well. 1 multiplied by 2 by 3 is 6. So we need to return the list of all possible expressions by adding those things into it. The second example is 2, 3, 2. Target is 8. We can multiply 2 by 3 to get 6. Add another 2 to get 8. There are different orders of doing the addition and the multiplication. They all equivalent, so we got 2 results in the final list. The third example is 105. Target is 5. We can use 0 plus 5 to get 5, or we can choose not add anything in between 1 and 0. Basically concatenating the 2 adjacent digits into one larger number. 10 minus 5, we can get to 5. So just considering all our choices now, after we read through this 3 example, let's say that we have n digits. There will be n minus 1 spaces where we can insert an operator, and that's 3 different choices at every location. Actually 4, right? So we can choose to insert one of the 3 operators. We can also choose to ignore that space and concatenating the adjacent numbers, digits. So we got 4 choices at n-1 location. So that leads us to total possibility 4 to the n-1's power. And if we made all the choices to form expression, to evaluate that expression to get to form a final value to compare with this target value, would take linear time. So the total time will be m multiplied by 4 to the n-1's power. So this is the time complexity to examine all the possibilities. This is just the brute force. I think it's the lower bound and also the upper bound, right? You shouldn't do really worse than this, and it's also the lower bound, because if we don't try one of the possibilities, how are we gonna be able to tell it's not gonna be add up to that target value? You might think hard, but I'm not sure if you can have something that's better than just try it out. But it does look scary, 4 to the n-1. So when n is large, this exponential thing is it's pretty large. Let's look at the fourth example. We have 0 and 0. So the target is 0. We can do addition, subtraction, or multiplication. They all evaluate to 0. But we couldn't do the concatenation because 0, 0 is just not a valid integer, I guess. They will only allow 1, 0 without the extra zeros parted to the left. So we need, in the code, we need to handle this case. And the last example, we have input string. I guess there's no way to form that target, so we return an empty list. Yeah, so pretty much we have to enumerate all the possibilities, and for that the time complexity is here. So there are, then it's to determine which way we do the exploration. We can do like a BFS kind of fashion, right? We try all the possibilities and just push all the partial possibilities onto a queue, and just keep growing that, and in the end, every possible candidates got popped out and evaluated, and decisions has been made. That would be a terrible idea because we will store too many of those partial expressions in the memory. So it's going to be terrible in terms of the space utilization. A better way of doing that is to do DFS. So we form one complete expression and then backtracking to the previous decision and try another decision to keep going until we reach the end. So in that case, the maximum number of stuff that we keep tracking in the memory is going to be linear. So just going to note it down here. So even though that doing BFS or DFS, they pretty much take the same time complexity, but the DFS is going to be more efficient in terms of space. And then we're going to talk about how we actually do the evaluation, because we just take granted for in the analysis that we're going to have a linear time algorithm to evaluate the possibilities. So how are we going to do that? We can scan through one of the candidates through left to right and just keep accumulating sum, and whenever we make a new decision about an operator, a new operator, and a new number, we just keep we just keep incrementing or decrementing or modifying that accumulative sum. Not necessarily accumulative sum. Yeah, but you know, when you add something multiplied by something, it's an addition. When you subtract, it's equivalent to add the negative of that number. So we just keep a total, running total. I guess running total is a better name. Yeah, running total. And when we scan through towards the right, when we see a new operator and a new number, we just do the updates. So let's make a more concrete example. Maybe like 5 minus 3 plus 2 plus 4 plus 5 multiplied by 2, I guess. Let's work through how this works. Let's say that we have a total to be 0 in the beginning, and then it should be the first number in the total, so initially. And then when we see a negative sign and 3, what we would do is just decrement total by or increment total by the negative of the digits. And if we see addition, then so the total becomes 2. We see plus 4, so we would just increment the running total by the number. We get 6. And then we see another 5. We just keep doing this. Until we see this multiplication sign, which means that we have to revert the change from the last operation, which is add 5. So, and we have to add another multiple of the last addition. Yeah, so basically cancel the previous addition and add a multiple of that previous addition, so that the total can be correctly updated. So for that reason, we have to keep track of the previous addition. Let's say that we have another multiplication here for a little bit crazier, like 3. So what's this here? Total is 11, subtract 5, we get 6. 6 plus 5 multiplied by 2, we get 16. So what's this being added? This is 10. So we get to we basically get this number and add this, so it's 36, right? Yeah, it's 36. So yeah, so basically when we do the one pass through scanning through the strings, which is separated by the operators, we're gonna have a running total and have some logic to deal with subtracting, addition, and multiplication. The important part is to remember the previous addition. So that for the multiplication to work properly, we have to remember this. So that's pretty much how we evaluate a candidate string. And I guess one last thing we need to figure out is how to determine the concatenations. So if we remember the current location that we basically is to form this. Let's say that we parsed this through here. The choice has been made until this i's location. We can how we determine whether we concatenating this two or even concatenating more. What we can do is to do a for loop actually, just for every possible slots in between the digits that we haven't made a decision on. We can make that decision. Yeah, so we can form the number that's after the operator sign by num I to j. We're basically getting that, converting this to a digits, and add that together with the previous operator, and then keep going on. So that's pretty much how we handle the decision on concatenating. Very last thing is to handle the code. The code should handle the 0, 0 case. So that's pretty much it. Let's code this solution up. We're gonna have a helper function dfs, and we're gonna call this function on the input string. No, not input string, on an empty starter, empty candidates. And this would take a candidate string, which is processing until the i's location, and then we have a running total for that previous thing. So this total is basically it's basically evaluating the expression until the i's location, and then we have to remember the previous addition. So with this, in the first thing that in this DFS call is going to be determine whether this candidate can be promoted to a possible string possibility and being put into the solution. So the logic is going to be we processed everything so that the I location is going to be the length of the input string, and we have a total to be equal to the target. So this is the promotion of the candidate, and then we determine the insert of those concatenating of those digits. We basically try every possible concatenation until the end, towards the end. So the string for that digits is going to be num I to j, and we try to convert it into an integer number. Then we have to handle this 0, 0 here. So if it starts with a 0 and it evaluates to a 0 with this int conversion, then there's a problem, because we shouldn't have a 0, 0 that's we shouldn't have an digits 0 with a leading 0 in the string. No. This is not right. Sorry, the logic is it's a little bit problematic. So if I have just a one I, right, one thing here, j is equal to I plus one, the very first number here. The s is gonna be just single digit. If there's a single digit, this logic, the second thing is not work. It does not work. We should test whether the stuff we grabbed is a single 0. Yeah, this will be do. Yeah, this will go good. This should be good. So this is testing. Yeah, this is testing if we have anything like multiple 0 be together. And then is the recursive call for DFS. So once we determine the digits we need to add to do the evaluation, and we just try 3 different operators. Make a copy. So it's for the recursive call, it's gonna start with the previous ending location, right? And the total will just update that based on the operators. The only slightly complicated part is dealing with the multiplication. We have to subtract the previous addition and update that by the multiplier, and we have to return this current addition. Let's use some space to make this a little bit nicer. This third one is too long. You will no longer. You will never look really nice. Give up. Yeah. Anyway, so this is pretty much the recursive call. Then there is only one thing now that then need to be handled. That is the initial case where we don't have a operator. All we have is to convert convert this into a string. That's now a starting string, a starting number for the calculation of the total. So that's represented by the candidate being an empty string. So if that's the case, we're gonna call DFS on the just converted number. The total is gonna be that number. The last addition is that number, and the location is j. Otherwise, we just do a recursive call. So shifted those over. And we got some initial number in here, which doesn't matter. This is solutions. Okay, let's see. Let's try run through some examples. Oh, I have not calculated the n. Okay. All right. Let's add some more examples. I'm a little bit worried about this 0, 0 case here because I was a little bit not very smooth in here when I code it. So let's just add another case here to see if all the cases are okay. It seems okay. So yeah, so let's run it. Alright, so yeah, so this is the code, complete code for this solution. It's a DFS search, and the reason for that is it saves a lot of space compared to BFS, because it does not store as many intermediate expression as BFS. So you just keep trying to just add add one number for the evaluation, and just trying to go as deep as possible, meaning that they try to come up with a complete expression as fast as possible, and make a decision whether we add it or not. If it's not, that's something we should keep. We just discard it and try another alternative. If we do BFS, it's gonna keep track of all the intermediate thing. So that would be a lot more space. The time complexity is this. N multiplied by 4 to the n minus 1. It's exponential, so it's quite time consuming. But I guess one of the problem here is you might not realize that you have to try all the possibility, and stuck in the thought that there must be some ways I can determine some of the explorations I don't need to do. How do I come up with a schematic kind of way to determine some possibilities we don't need to consider? That would be, I don't know, if you're stuck in that, I hope that the interview can suggest to you to try to just solve it with the most obvious way, and because there are a lot of details actually in this handlings. So yeah, so that's the question today.